Good morning, everyone, and welcome to our webinar. We are going to give people a few more seconds as they funnel in, and we are going to begin shortly. In the meantime, hi, Ching. How are things down there in Australia?
Fantastic. Thanks for asking, Felipe. It's a lovely day here in Australia. How about yourself?
By the way, I don't know even if we are in the same day. I mean, we are, what, about 12 hours apart
Yeah,
from
I'm
each
I'm in the
other?
future.
Yeah,
Yeah. Living in
yeah,
the
yeah,
future.
you are
It's
basically
great.
in the future. You made
There's
a
good
time
things coming for
machine,
you.
something like that. Yeah. But yeah, I mean, here in Brazil, things are pretty much very hot. I am melting, and but yeah, things are cool. In general, all good. Thanks for asking. And guys from the audience, thank you so much for tuning in to hear from us today. Please take a chance to introduce yourself in the chat. Let us know your names, where you're from, and what brings you here today. All right. So, all that said, hi everyone and welcome. Before we actually get started, allow me to quickly review a couple of housekeeping items. We welcome your questions, and please use the Q&A button located at the bottom of your screen to ask your questions. And please remember, you can enter questions at any time during this webinar. You don't have to wait until the end, and we are going to try to answer as many questions as we can at the end of the presentation. All right. Also, please note that today's webinar is being recorded, and we are going to email you with a link to the recording and the slides following the event. All right, go. So before we actually begin with the actual webinar, we are pushing a quick poll question for you to answer. How familiar are you with NoSQL data modeling? And well, I guess I know which option Chin will pick for that one.
Yeah. Just not. I mean, that's why we're here,
Not
right?
at all.
You're
Yeah,
gonna
exactly.
teach me. You're gonna show me the way.
Yeah. So please let us know on which stage you are currently. If you are familiar with the concept already and whether you are already using it in production, do let us know what's your use case and whether you are somewhat familiar, but maybe you are not yet adopting it. Perhaps you are currently struggling with it and trying to learn more. And in this case, we hope today's session is going to be useful to you. Maybe you're getting started, or perhaps you never tried it, right? So thanks for those responses. And with that, let's get started. So, guys, my name is Felipe, and I will be your host for today's webinar on what developers need to unlearn for high-performance NoSQL. So this webinar is the first part of a series we are making to demonstrate the path from a relational world to a NoSQL, how the path from a relational world to a NoSQL database looks like. We'll be using Postgres for our relational DB, and of course, ScyllaDB as our NoSQL one. All right? So, for those of you who are not yet familiar with ScyllaDB, it is essentially the database behind game changers. Organizations whose success depends upon delivering engaging experiences with impressive speed. ScyllaDB was built with a close-to-the-metal design that squeezes every possible ounce of performance out of modern infrastructure. And this effectively translates to predictable low latencies, even at high throughputs. And that's our goal in today's webinar. With such consistent innovation, the adoption of our database technology has grown to over 400 key players worldwide. So, many of you will recognize some of the companies and logos pictured here, such as, for example, EA Games, who is using ScyllaDB for personalized advertising to their players, or also Epic Games, who is also part of the gaming industry, Disney Plus, Hotstar, Tubi TV for mid-streaming, and also Comcast, of course. Companies in retail and e-commerce such as Fanatics, and so on. All right, so as it can be seen, ScyllaDB is basically used across different domains and across different industries, and it can be a very good fit for different types of use cases. So typically, your company probably have a use case that is a perfect fit for ScyllaDB. And in case you don't know it yet, please get in touch with us so we can discuss and around the possibilities that ScyllaDB can unlock for you and your company. All right? So, quick introduction from us. My name is Felipe Mendes, and I work here at ScyllaDB. My main role is to effectively work closely with users like Tim during their ScyllaDB adoption journey. I gather requirements, I offer consultation, and I ensure that ScyllaDB is the right solution for your needs. And as you guys may guess, partnering with me today, we have Tim Koopmans, who is our star of the show, for me, our troublemaker. So, Tim, why just to simply go ahead and please introduce yourself.
G'day everyone. Thanks, Felipe. I didn't write this slide, by the way, so this is, I believe Felipe is doing. But yes, I do like my Tim Tams, and I've shared quite a few packets with my colleagues at ScyllaDB, and I believe it's quite popular. Do you like Tim Tams, Felipe?
I love Tim Tams, particularly. Yeah. I prefer more the Tim Tam challenges. You do need to introduce the audience in a later day.
and as Felipe said, I'm the developer for today, so I'm going to show you some of my own very hacky fictional database application that I'll get into shortly. I guess that makes me the Aussie with ideas. I'm not sure of the pun there, but I do know that yes, we do drive on the correct side of the road, which happens to be
the right side.
Yeah. Actually, we drive on the no, that's not right, because we drive on the left side of the road, which is the right side.
So you drive on the wrong side.
Anyway, it's not important. It's not important for today.
Yeah, awesome, Jing. Thank you so much for introducing yourself, and let us know in the chat on which side you drive, if it's in the correct one or in Ching's sides. So, guys, moving on. To provide you with a bit of context, recently Ching started to explore ScyllaDB and found himself, well, in trouble. But not because ScyllaDB is hard, nor anything around that, but rather because the deep knowledge that he brought from working with other technologies, such as Postgres, eventually led him to make some wrong application decisions. Luckily for Ching, and unluckily for me, I was tasked to assist him on that task of demystifying ScyllaDB and explaining and walking him through on how to get the most performance out of it. Given that short intro, Ching, I have two questions for you. So this webinar is titled, What Developers Need to Unlearn for High Performance NoSQL. And I particularly find the word unlearn very interesting here, as it carries this notion that there are, usual habits that software engineers tend to carry on from their previous experiences, which are not necessarily wrong per se, but may make it harder for you to learn and adopt a new technology. So I would like to know your thoughts on that, and also for you to give us a brief introduction around the application you're building, why you believe ScyllaDB is a good fit for it with regards to performance, and what you're trying to accomplish.
Okay, great. Well, yeah, thanks for that. I guess, I mean, there's that the old adage of you can't teach an old dog new tricks. I'm not saying that I'm the old dog here. But yes, I think there's like a lot of cognitive biases when you've been doing something for a while. And so my first impressions, having worked with relational databases for some time, is that, when you start to get into the language and, operating within, say, ScyllaDB, it all looks very familiar. I mean, the syntax is quite similar in terms of query and all that sort of stuff. And so, I just there's a lot of assumptions or just inbuilt knowledge, or perhaps just automatic memory, let's say, when you're doing things, like I can create an index, in my sleep, I guess, and then I just expect that maybe that works the same way. But we'll get into that, I guess, as we go through today. So there's a lot of sort of just inbuilt sort of biases, is what I'm saying, that it can make it difficult to unlearn. You have to be willing to sort of drop some of these preconceived notions of how things work and just look at ScyllaDB with a fresh set of eyes. So that's what I'm aiming to get out of today. In terms of the application, I should share my screen, I guess. Let me.
Yeah, please do. Let's see what you are building and what you have prepared for us today. Well, for me particularly, right? Let's see if there's any question you have I am unable to answer. I hope not.
Okay, well, I have this. I've created a fictional, let's call it an Internet of Things app. And in fact, if you want to grab this, if you go to just my name on GitHub, because this is I don't think this is worthy of publishing on the ScyllaDB domain yet, this application. But if you go to my name and just look in the repositories, there should be an app called Rusty's Racing. Now, just as context for that, I've got young kids. They love the movie Cars. I don't know if you've seen it, but Rusty's is Rusty's is
Lightning McQueen is the best.
Yeah, Lightning McQueen. No, I like Rusty. And actually, we're going to do the app today in Rust. So cool. I've got this app here, sponsored by Rusty's Racing, and it's a fictional app. It's basically, if you can imagine all of the cars going around the Lightning McQueen Grand Prix, whatever they call it, and they're all reporting that telemetry data from the race cars themselves. So we're collecting race car metrics, and we're collecting things like, to begin with, it's just very simple. It's just, a whole bunch of events that are coming from all these cars in the races in near real time. And there's going to be quite a lot of these. So at the moment, I think I've got things like the top speed and the acceleration factor and, I don't know, like performance or braking or handling or whatever you want to call it. And I was using Postgres to basically solve this. And I started to realize that, I'm going to have this giant table, let's call it race car metrics. We'll get into the details soon, but it's potentially going to have millions of these records just being streamed into the database in real time. So it's potentially quite wide as well. Like it's, I've just listed 3 of the metrics, but there's any number of things that high performance race cars are being measured in real time. So I have this super wide column kind of thing, which is growing at an exponential rate in terms of rows per second. And that's why I started to think, well, yeah, it'll obviously be good for the first couple million rows in Postgres. I don't need to worry about it. But what happens when I have like billions of rows in here and I want to start running aggregated queries across it? That's why I'm sort of looking at the NoSQL thing today.
Perfect. And I assume you are having some trouble, all right? Getting it to work with ScyllaDB.
Some fictional trouble. Yeah, of course. I've got my. I can. Do you want me to walk you through, or should we go through the app a bit, or do you have more slides?
First show us. We do have tons of slides here. If you, we can always walk through slides. But first,
let's have a look at it.
Yes, just see your application running, what it's doing currently, if it's working, right?
Yeah, let's actually see if it works. That's always good. Just to sort of run you through the architecture, it's just basically a simple Rust application. At the heart of it, it's serving up some content on like HTTP routes. So I'm using a crate called Axum, which is really nice, and it lets me. I've just got 3 routes here. And as you can see here, I'm doing things like, get me a list of all the drivers and sort them by the last updated time in the database, maybe the max speed for a particular driver, and let's say get the max speed since a particular time range for a particular driver. So that's kind of like what it looks like at the web level. I'll see if it actually runs, which it should just be able to do it from here. And it looks like it's compiled. So that's always a good sign. And this is the little application serving up data on port 8000, like a good little web app should. And hopefully that's working. There you go. So it's returning some information. It was a terrible query time, by the way, 4.69 seconds.
Yeah, 4.69 seconds. Yeah, I can see why you are trying to improve that.
Yeah, it definitely needs improving, and that's why I was starting to think. Yeah, there you go. Maybe
much better.
The startup,
much better, but not great. Still, yeah.
700 milliseconds even in relational world is like
Yeah, yeah.
eons. That's quite terrible.
No, but
But yeah,
in compared to 4 seconds.
so yeah, I'm a back end developer, so don't criticize me for my front end skills here, which is just raw text. But I could imagine whoever's managing Lightning McQueen is like sitting in one of those little booths, where they're calling the shots and looking at all these metrics. So this will end up being a big dashboard of all these wonderful metrics. So this is as far as I've got with the app before I started thinking about performance. And yeah, you can see here as well that it's doing a bunch of writes in the output, and I'll sort of explain what that is. Let me just sort of minimize some things to give you a bit more of a feel. So the main logic is sitting in here in terms of just serving up the content and like I said, just serving that up over port 8000. Yeah.
So let me ask you just what does the slash does? The slash in the point? Drivers by last updated. What is that?
Oh, this sort of stuff.
No, the first
this
one, the
yeah.
root.
So
yeah.
So what I did, so I've put all my logic into just another file here, another module called DB. So this is where all my sort of Postgres stuff is, and in fact, before we kind of get into there, I did read that it's good, good to sort of lay out your data model, right? And so I thought that might be handy today. So this kind of gives you an idea of what we're dealing with in the Postgres side of things, and this is what I'm hoping to convert into ScyllaDB stuff. But yeah, like I said, we've got like a table. It's called racing car metrics, and it's just one table for now. I haven't really thought about sort of like splitting this up and all that. There's no like foreign key stuff. There's no complex sort of
joins. Right.
It's just one big sort of giant table. I'm actually using a UID for the ID. I probably should have called that UID, but anyway, the ID column is a UID, and the reason, just in case you're wondering, I chose to do that because I just wanted to make sure that every event is unique and captured. You know what I mean? And I guess like just old habits as well, just not using like sequential numbers that are easily guessed, etc. So the data ends up looking like this. In fact, I'll just show you what it looks like. Might be easier. Might be easier to visualize. So the data's are streaming here. You can see this UID. We've got the driver name, which is basically what we query by, and then sort of integer values for these top speed, acceleration.
So you can have several entries for a given driver because those entries will be each one identified by a distinct weight.
Yeah,
right?
exactly. And so this data is just coming in like literally just spewing out of the cars. They're just like high bandwidth, pumping it back into this system, and everything's timestamped. So that's the meaning of the last update. So as we write that row, we chuck a timestamp on it as well. So hopefully that explains the table. And then you had a question about like what does this function do? Drivers by last up.
Yes.
Yeah. So yeah, I just separated out my database logic from say it's not really MVC, but I'm just separating out data retrieval from actual serving content. And yeah, that's what's in this file. So there's a couple of things that I'm doing here. I do have some questions later about like connection pooling and if I have to worry about stuff like that, but we'll get to that. But
yes.
Yeah, like at the moment in Postgres, I'm just using a thing called BB8 to sort of act as my connection pool. It's like a nice little crate. I'm also using Tokyo here, so everything's async and nice and fast, which is nice. And yeah, it's pretty lightweight. Yeah, and so just like running through what that query does, drivers by last update is just getting the driver name, top speed from racing car metrics, and it's ordering it by the last updated timestamp, and it's just limiting it to the last 5 rows. So that's all you're basically seeing in this view. It's like the last 5 rows from that table.
Yeah, so I was wondering that because I do see sometimes you get duplicates, right? So for example, Jerry.
Exactly. So it's not it's not keyed or anything like that. It's just basically get me the last 5 rows. So I guess if this was in a wider dashboard, this would probably just have like some little web socket there, and you just see the data streaming past and give you that kind of good feeling that everything's still, everything's still phoning home kind of thing. So that's all that query does. And then there's some other queries in here, like, when I want to, actually, I think I wrote it in the README. So just say I want to look at the max speed for a driver. I've created that route so that this is what it would look like. So this is the max speed for the driver named Stacy. And this is also real time as well. These are, I really need to fix these queries. I should put some indexes on, but ignore the terrible performance. And then, if I want to see, sorry, what did you say?
No, because very clearly, I mean, I am definitely no relational expert, but just by seeing your data model, it's clear that you are scanning all weeds for a given driver, which can be very inefficient, right?
Yeah, and like, I'm not going to go through and explain today how to index Postgres, but I do. In fact, I do have some stuff in there. So I think what's happened is I've just recently rebuilt this database for the webinar, and so you'll see here this particular query it doesn't have an index at the moment. So if I just put an index on this, which is based on last updated in the sort order, that should make it a lot quicker. So if I was to look at that one again, like this one is at 1 second. Pretty sure if I start to create an index on the database for that. Oh, by the way, I'm using IntelliJ, so I know that makes me also like an old dog. Everyone has their preference, but I'm using this. But it's just nice to be able to sort of have a look in here and have a bit of a GUI to it as well. So I know a lot of people.
If you want to
I've
feel
just
better,
applied that, and look, that's come down a lot. Yeah, so we got some microseconds in there. What's it's close to a millisecond, but sometimes it's microseconds. So that query is a lot better. And I can probably I've got indexes for the other ones as well. But the reason I did this, Felipe, was I thought it would be good to so you could sort of see the schema that we're working with, and like what indexes I've used, because I was in my head I'm thinking we need this information, right, for ScyllaDB, or maybe not. I'm not sure.
Which information? I'm sorry.
Well, like what the queries are, what indexes I have.
Yes, exactly. So it's very good that you actually have put this together, because this is effectively what we need. Well, your schema helps for us to understand what you're trying to accomplish, but the most important things we typically want to focus on is not on your schema particularly. It's rather your queries. So
Right.
I was very interested when you were showing me all the select queries you were running, because this effectively gives us an idea of how you should be structuring your data model on top of a NoSQL database such as ScyllaDB. And
Right.
I think for the audience here listening to us, that can be perhaps one of the most important advices I can give out of our talk today. I mean, start from your queries, think about all the access patterns that you need to query against your NoSQL database, and then only after you start building your schema. That's very different when you come from a relational data model where, as you did, right, Ching, you simply added all the fields you wanted because it's what made sense for your application.
Yeah.
And then after, when you saw performance problems, okay, I will simply create an index and see what will happen after. Maybe it will be better. And hey, it was better. When you transition to NoSQL, it's actually different. We get your requirements or your queries, and then we start structuring your schema around your queries.
Oh, that's good to know, because I did read some material, and I heard this thing about query first design, but I guess we can talk about that later. I haven't I've got code here that we can get into about how my first forays into, but maybe it'd be good to also show you what's writing to the database, because I've only just sort of shown you the read path, I guess.
You can, but as I can imagine, your writes are pretty much regular inserts, right?
Yeah. I've got it here. I think got it down here
Mhm,
somewhere. Oh no, I mean it would
mhm,
just be in the code, right? Let's look at the code. So yeah, these are the queries that I have linked to the routes, and then I think somewhere, yeah, in here I just spawn like a background process to do, to simulate the writes, and I've just
mhm.
called it a very unique name called writer, and that's my cat. Sorry about the
Creative.
cat. Uh, yeah, and so yeah, it's just an insert basically, and maybe
Mhm,
yeah, it's doing is inserting as fast as it can. In fact, no, I've got a
mhm.
little microsecond wait here. So
It's fine.
yeah, when you're looking at it, but I thought it'd be interesting to see how quickly I can write. So like, let's just stop that and comment out this part because now it should just iterate as fast as it can go. And if I was to run this in here
Then it's
again.
going to break your app.
No,
No,
it's
and
just
as
complaining because
unuse it,
I'm not
yeah,
using it. Yeah, Rust
and
is
import, yeah.
nice. So yeah, it's actually not that fast. Oh, it's maybe 1,000 rows per second is kind of like what it's spewing into the database. Um, so
That's
that gives you
very
an idea.
slow, to be quite honest. I mean, I know you're running on your laptop, etc. now, but 1,000 rows per second is not that much.
Yeah, I've just got to remember how to. I could probably. What is my password? I don't know. I think it's just Rusty's. Um, sorry, I'm at this squishy little screen. Um, Yeah, it's like doing about 1,000 inserts per second. Um,
Hmm. But you can
and
see that on the activity side, it's actually the double, right? Because of your
yeah,
indexes.
yeah.
Yeah.
I mean, yeah, of course, with the
Hmm.
indexes, and you'll see, some of the write
Wall
ahead
sync,
log
yeah.
stuff
Hmm.
as well. And
Yeah.
in fact, if we just look at what's to I think I just broke my code there, but yeah, I guess I'm kind of maxing out. But yeah, like you said, this is on my laptop, so um, yeah, it's hard. It's going to be hard to compare performance, right? Like it's this ballpark at the
Hmm.
moment. Yeah, but
Yeah,
it would be
precisely.
kind of interesting to see, I guess, what we can do with ScyllaDB.
All right. So, Ching, uh, what about if we start switching to ScyllaDB now? Let's give this application a boost and let's see what are some of the changes we need to make in order to make it working. It definitely looks like a very good use case for ScyllaDB to me. First,
Yeah,
because it's append only, as you said, it's primarily ingests data.
yeah,
Your queries are all fine. I mean, your inserts, there's nothing specifically special about those.
no,
So for this application specifically, we are going to center mostly around your reads. But if you had a delete, for example, if you had a situation where, for example, hey, I want to delete all records which had a specific acceleration, then that's when probably would be interested in your deletes or update clauses. But for now, let's focus only on your reads. And I
yeah,
assume, Tim, that you already tried to migrate this application to ScyllaDB. How is that working out for you?
yeah. Well, I did. I created a feature branch, because I'm a good
Ah,
developer, right?
awesome.
And
The only
I've
problem
got
is
that
that
here.
it's not yet merged, right? This feature
No, not it's
branch
not
is
on
not
main.
yet.
Yeah, it's not on main. But if you want to have a look on GitHub, you can see it. I mean, it hasn't passed peer review.
But I mean,
And
our goal here is to move that feature branch to main.
yeah, absolutely. I think, well, so the first thing is I need ScyllaDB, right? So I
Hmm.
didn't talk about it before, but I'm just using Docker Compose
Hmm.
I did some experimentation here. I've left myself some notes. But basically I'm starting like a 3-node cluster in
Hmm.
for ScyllaDB. So I'm calling them uniquely called ScyllaDB1, ScyllaDB2, and ScyllaDB3. And I might, because that takes a bit of time, like this clustering thing. And I should note that this is pretty straightforward. I didn't really have to do anything. I just had to point like there's a command line argument called seeds, and I just point
Hmm.
it to the host of whoever the first node
The
is,
previous
basically.
container.
Yeah, so I just did that. So I'll just start that so we can hopefully get that all running, and just minimize that one, and I'll start ScyllaDB 2. And I mean, you can just do Docker Compose up as well, by the way, man.
Yeah.
I'm just
But you are an
saving
old
typing.
man, right?
I'm an old man,
Yeah.
just using my mouse, and so I can gesture wildly.
Yeah. No, it makes total sense. I mean, I assume the while ScyllaDB is starting, you probably have some questions, right? Do you want me to explain
Yeah,
what
I've got a lot of
ScyllaDB is?
questions actually.
Okay.
So because I did the university course, I know there's a bunch of flags that are useful. The
Mm-hmm.
first one that I tried was SMP1, which I understand just pins it to like one core. Is that right? So
It's not necessarily CPU pinning. You are right that you are going to restrict the ScyllaDB process to be using one CPU, but it's
yep,
not pinning, because pinning is when you assign it to a specific CPU. In this case,
yeah,
it's going to be assigned to whatever CPU you have available
yeah.
for
Okay,
processing.
so
Yeah.
because I've read like there's a lot of shard per core stuff, and I wasn't sure if like
Mm-hmm.
that's where this is happening, or this is
So
just more for development mode, right? Just to restrict the performance
yeah,
of the. Yeah,
so the thing is that, as you may guess, since you are running in Docker Compose, ScyllaDB can get very resource intensive if we configured it, the Docker image, if the Docker image were configured to use most of your system resources. So what happens is that we recommend you to limit to use only one CPU, because we don't want you to fry your computer.
yeah, yeah. Right. So I'm running 3 nodes, and I've got
Mhm.
SMP1 on all 3 of them, and yeah,
Mhm.
like my Mac is fine. Like the fans aren't spinning. It seems good. Now this I did come across this issue when I didn't have this flag. I got this issue, standard runtime error. The most common cause is not enough request capacity in AI, the async IO max NR. And I Googled it.
Mhm.
I found a bunch of stuff which is just like, you should increase this setting, but then that was like for Linux, and I'm on Mac, and then I couldn't increase it on Mac. And then I think I found in a forum post that you can actually just do this reactive backend equals epoll. I was wondering if that's
Mhm.
okay, because that seemed to get around that particular problem. Like, is that right? Or
So yeah, that's a good question. So your specific environment is Docker. So in
yeah,
this case, one thing you could do, you don't have to do it now, would be
yeah.
to simply run your cluster using a single container. Because after all, you are
Oh, okay.
simply developing it, right?
Yeah. So I can run
Um,
3
uh,
nodes in one container. Is that what you're saying?
No, I meant just to spin up a single node
Oh, okay. Yeah, right.
rather than 3 nodes. I mean,
Yeah.
because after all, you're simply developing it, your application. So you're not going to be using it for production purposes currently. This
Well,
is
yeah, I
going to
had
be
not. Yeah, remind me to
much less
ask you about
research
that.
intensive. Yeah,
Yeah,
this is going to be much less research intensive, much simpler for you to get started. You don't have to
yeah.
spin up 3 nodes, wait for them to join, etc. and so forth.
Okay.
But yeah, since you faced this error and since you already started a 3 node cluster, yes, so you are effectively, one of the things you needed to remember, and that's a very good question, is that when you run Docker and your host operating system is a Mac, what happens is that Docker, they effectively spin up a Linux VM, and then the containers you ask to run, they run inside this Linux VM. So
Yeah.
that's why it's not so simple for you to increase this parameter. There are some ways in the internet you can look after it, but it's not fun.
Mm,
So if you spin up a single container, you will be fine. We know it works. You will not run into any error. But if you
okay.
do, if you still want to start, I don't know, 3, 6, 9, 12 containers, then
Mm,
you will probably need to specify a different reactor backend in order to process your requests. And probably you want to know, okay, so what is this reactor backend
yeah.
parameter all about? So ScyllaDB effectively is built on top of the C++ framework called C star. And what C star does is that it effectively runs one thread per core that you have in your cluster. In your case, it's going to be one thread in a single CPU because you specified SMP1. But in a production cluster, it's going to be one thread per core. And for the name that we give to each one of those threads that are assigned to specific CPUs is what we call a reactor. So that's why the parameter name is called reactor. And why is it reactor backend? It's because the way this reactor, the C star thread, is going to do polling for incoming work. And since in C star, everything is done asynchronously, that's why you're having the error that you ran out of asynchronous IO. The name of the parameter, the number of,
Got it. So for anyone that's just getting started, just to sum up that, for anyone that's just getting started, maybe just run one container if you're just developing. You don't need a 3-node cluster. And if you do, and the SMP flag is good for like restricting the amount of CPU. If you hit this request capacity thing, there's instructions out there on how to tune, the kernel settings or whatever, or you can also just use Reactor backend for now, which might get you past it, especially on a Mac. And then the other question that I had here, sorry, just to keep this, but I'm sure people are going to get stuck on this, is I saw in the labs that we use the over provision flag, but when I did this in Docker Compose, the container just crashed, and it looked like the over provision flag was already set. So I'm really confused. So I commented it out because it seemed to be like basically not working. And so I was just wondering, like, do I need it?
So
yeah.
So the flag over provisioned works. Probably you passed it incorrectly because one thing that it may require is a flag. Sometimes it requires, some flags require yes, true or false, and some flags
it's
don't.
not like a Boolean.
It depends on the flag, right?
Okay. So maybe I just messed that up. Maybe it needs like a 1 or something.
But to address your question, whenever you are starting ScyllaDB in a container, by default, the developer mode is already enabled. And what happens is that over provisioned is already enabled as part of developer mode. Effectively, what over provision does is that it makes ScyllaDB run with using less resource intensive settings. So again, it does not fry your laptop.
Okay. Cool. All right. I think that's maybe the only other thing to talk. We'll get into like connecting to ports and stuff because I do have some questions there. But for now, what I've just done is I exposed, like if you look at just Docker here, I've exposed, the 9042 port, which is, I understand you can use the CQL shell tool to connect to, and I've just called them like 90421, 9042, 9043. Just so that I in my head I can remember the different nodes. And then
that's not cool.
Not good.
Not good.
Okay. So don't do that.
Yeah, don't do that. All nodes in your cluster should be listening. Well, so here's the thing.
Sorry.
All nodes.
Is this like, because I was trying to look up ScyllaDB ports, like what ports do I? And I think it was this one. No. I feel like there's like a port. Anyway, I can't find it now. But there was like a table.
I think that's the one. If you scroll down more,
maybe I have to scroll down. Oh yeah, here it is. Yeah. So I thought, okay, so 3-node cluster, they need this internode community. I'm not using any TLS SSL because I don't think I am anyway. I don't have any certificates configured. And then this is the port that I was talking about, the SQL native transport port. That's one that I think I need to, if I want to hook up a SQL shell. And then the other thing that I noticed was this 19042, which is like the shard aware, because like I've got questions that we'll get into the driver, but I have questions about how the driver connects as well. So yeah, but you're saying this is wrong. I've got this wrong? Is that right?
Yeah. So can you get back to your shell and show us the output of Docker PS again?
Yep.
Yeah.
All right.
Yeah, let me see just the Scylla containers. Yeah, so that's what I want you to understand. So effectively, your three Scylla containers are listening on port 9042, right?
Yep.
And what you're doing to your local machine is that you are binding different ports to port 9042 in the ScyllaDB containers.
Yeah.
What happens is that if your application is going to connect to localhost on your machine, then it may not be able to route traffic to the other nodes because it's not going, effectively what happens is that your application is going to connect to the first node, and then it's going to query an internal system table, and it's going to retrieve metadata information from the cluster and then try to open connections to the other nodes using that information it found. And this data is not going to match the binding you made.
Okay. All right.
Does it make sense?
I kind of follow. I guess maybe what I was trying to do was, the direction I was heading.
You know what?
I want to be able to connect to this, right? So if I added like, and I realize you can just use Apache Cassandra. I downloaded the drivers, and I think if so if I connect to 9042, now this is the other weird thing. Is this right? I read in the manual that I just use Cassandra as the username password. Is that correct?
Since you started a container using the default settings, you can use whatever user and password you want. It doesn't have to be necessarily Cassandra, because once you start a container, by default, authentication is not enabled. You have to specify it on the command line. So it doesn't matter much. You can even pass no user or no password. But Jane, it looks like to me that you have some misconceptions, which I want really to clear out with regards to drivers. Do you mind if I steal your screen share?
Go for it. Yeah, go for it.
Yeah. Just a sec. So I kind of thought that you would have this misconception. So I created this section related to drivers and application side. And before we actually address your question, I would like to quickly take some time to address a common question we get from the community, which is, which driver should I use? And in general, you should be using a shard-aware driver. And Chin, you just showed us in the web page that we have that port 19042, which is for shard awareness, right? So in order for us to understand what shard awareness is, I want to explain to you how the driver connects to your ScyllaDB cluster. And here we are simulating this scenario where your application in Rust is going to connect to a single ScyllaDB node. So whenever you call a given node, the driver is going to ask, hey, who are you? Do you exist? And then the ScyllaDB node is going to reply back to your application. And in that reply back, it's going to add in the response the information that, hey, I am ScyllaDB, and I've got a given number of shards. And shard is again, how many CPU cores, how many threads the ScyllaDB node currently has, right? And then what's going to happen after is that, okay, the driver is going to say, okay, so you are ScyllaDB, cool. And then it's going to ask, and this is the process I was trying to explain to you, who are your peers, which means which other nodes exist in your cluster, what's the existing schema, so I can know to which table I should be. Is it okay for me to send the queries? Which queries are valid and which queries aren't? And then the ScyllaDB node is going to reply you back with that information, right?
Yep.
And then what's going to happen is that first connection your application did is going to remain open and always be polling against your node. And then your application is going to open several other connections, each one connecting to a specific shard in your ScyllaDB node. And this view is just specific to a single node. So if you had, for example, a 3-node cluster, such as you have in your setup, you would see your application opening additional connections to each shard of each node. And that's effectively what shard awareness is. All right.
Okay.
So if you'd like to know more about control connection, I added a link here. It points to our Java driver, but all drivers working pretty much in the same way. And if you are wondering what's the logic which a driver uses in order to connect to a specific shard, how do we know, right? How does my application know to which shard I'm going to connect? So what happens is that your application, your driver is going to initiate a connection using a source port such that the modulo of the shard count is effectively going to be the shard you want to connect. That's simple. Okay, does it help with regards to how a connection works?
It does, and I'm sure other people are finding this pretty useful as well. So I think what I'm going to have to do is like refactor what I've done, and maybe if I just quickly show you like how I've used the driver, and then we can, I'm sure people don't want to see me refactoring, but I think we'll just take that on the chin for now. And yes, I feel like I've done this wrong, but so I use the Scylla driver, the Rust driver. Pretty easy. Like you can find that online. Just add it to your crate, and then away you go. Do basically install it. And then I created like basically a new version of that database module called it SDB, NoSQL. And so that's got all my queries in there. But in terms of like connecting to it, what I've done is just set up using what's it called, Scylla session and the session builder, and I'm using that session builder struct to basically create a new session. I'll talk about why I'm using Arc, but yeah, in this case, I'm just pointing it to the 3 hosts, and I think it sounds incorrect to me. So maybe in another,
it's wrong.
We won't spend any more time on it. I'm conscious of just talking about drivers all day, but obviously I need to improve that. But I'm creating this session, and I'm just wrapping it up in like an atomic reference key, like Arc. Yep. If you've used Rust, you've probably used this because just then I've got like that shared reference to it on the heap, and I can pass that around the web app. So that seems to work in terms of basically. I think that answers my other question as well that I had. Like, do I need to use a connection pool for ScyllaDB? I don't think I do.
You should not use a connection pool due to the reasons I just explained. As you saw, the driver automatically manages it for you. It opens several connections, right? Yeah. And another thing you should not be doing, and it looks like to me you haven't realized that you are doing it, is placing a load balancer in front of your database. So you can say, hey, I'm not doing that. How come? You actually are, because you are doing some sort of network address translation, right? You are binding different ports to your host machine, and you are connecting to those different ports, which are then going to be mapping to a different port inside your containers, which you are not allowed to get traffic. So yes, you have a NAT and some sort of load balancing, which is not going to work. Which is why, again, I said, my recommendation is just start with a single container and play with that until you feel like you're ready to move on to the next step.
Okay, I'll do a bug fix branch and post it on that repository so that people can see the diff and and see what I did wrong. But thanks for explaining that to me, Felipe. Yeah, I'm glad. I
No
mean,
worries.
I got so far as like I did plumb out the rest of it in terms of, so yeah, I added this SDB file here. I don't think, let's not get into the schema stuff today, because I know we're going to have another webinar where we can go into the data model, but I'm really frightened to show you this actually. But I've got,
Why
I may have
frightened?
used
Are you like
ChatGPT,
afraid
but
of me? Oh, okay.
no, I'm just, I don't like to be wrong. I've already been like wrong multiple times today, but I'm pretty sure
Yeah,
this has
no,
got.
let's not look into this
Let's not
today.
look at
First,
that.
because we don't have the time, and second, because
Yeah,
yes, we are
yeah.
wrong.
Let's just
Sorry to
quickly.
tell you.
I'll quickly show you where I got to, um, and then yeah. So I created that. I think it runs. If I let's see if it runs. It's always
I
interesting.
love the developer mindset. I think it runs. If it runs, then it's great.
Job done, right?
Yeah,
No,
exactly.
no specs. um, yeah, so let's see what happens. Well, it's doing something. And let me see. Oh, no, okay. All right. I got a whole bunch of errors here.
Wow. Yeah.
I know what I'm
Mhm.
doing wrong. Like I literally, yeah. Okay. Let's not critique this, but actually let's make sure that we run this.
Mhm.
This actual. We'll do it in a. Let's see if I can run it just this way. I'm not going to go into SQL shell and all that sort of stuff because, you know, you can do
Yeah.
university courses for that. I'm gonna I'll create this table. Where is it? This one. So just so that the code can actually run. There you go. I think if I run it now, it should be writing stuff in there. And yeah, we'll definitely. Oh, it's pretty slow. But I'm sure I got a ton of mistakes here.
Mhm.
And yeah, well, let's not get into that today. The writer function is down. It would be down here, like I did the bottom. I got so many questions. I can actually take that sleep out. Let's be fair and do it like we're doing for the Postgres example. So there's no sleep
Let's
between
see
the
how
writes
it
now.
goes.
Yeah, and hopefully
Not any right. Oh,
there you
okay.
go. It's doing some writes.
And you
Yeah.
know
So
what's funny? Yeah, I mean, one can say that, hey, you are getting pretty much the same throughput as you are getting with Postgres, or maybe a bit less. But one thing you have to remember is that for whatever reason, you decided to start a 3-node cluster. So you are pretty much around there, but you are writing to 3 nodes at the same time concurrently. So
yeah, and I'm not
even even with this non-optimal data model, etc., I mean, we can see that the throughput is actually okay compared to Postgres already.
yeah, let's just say this is function, not form. I
Yeah,
mean, yeah, I'm absolutely confident now I've got stuff wrong, but that'll be in the next
yeah,
webinar, right? We're going to go through the data model and my queries. But yeah, this is kind of like for like, and like you said, we're writing to a 3-node cluster. I think I got the port, we obviously got the port mappings wrong. But I sort of got there in the end. Like and yeah, I think in another session, how much time do we have? We have about
we
five
have
minutes.
to wrap up really shortly. Yeah, no, we
Yeah.
still have about 5 minutes. So anything else you'd like to discuss for today?
I think like we've shown how people, how to install a driver, how to get it running with Docker Compose, answer the
Exactly.
questions about
It's actually
shardware
how to get
drivers.
started. Mm-hmm.
I think that's
Mm-hmm.
enough. Yeah, people can get up to this point. And I've got some queries in here which are, they sort of work, but I did struggle a bit with here, but I found that if you just refer to the docs on, is in the Rust docs for the ScyllaDB
They're
driver,
really
it was
good, right?
pretty straightforward. I ended up just using like a UID function because I couldn't figure out how to like, do that with a function like I did in Postgres. I was getting Postgres to do it, but in this case, I'm using the app to generate the UID, which I don't think is a big problem, and very similar logic. The only other thing that sort of caught me up was wrapping things in a SQL timestamp. So I get the type right, so it takes like a timestamp milliseconds, which I think is like a U64 maybe from memory. I can't remember. But
yeah, I think it's in U64 because it's effectively the number of milliseconds in epoch, right?
Yeah. So that seemed to be okay. I'm just using Chrono, which is pretty popular in a lot of Rust apps anyway.
Yeah,
So
I did the same. I do the same.
yeah.
I always use Chrono. Yeah.
And then I think that's all I wanted to sort of go through today. I do have leading questions for later, but maybe we need to talk about data modeling first in the next webinar.
Yeah.
Before I sort of go down this path, because I was trying to look for like performance improvements, but now having spoken to you for close to an hour, I realize I'm actually on the wrong track with my queries to begin with. So yeah, I think that's all I can show you today, or feel comfortable showing you today.
But just no, I think it makes sense, and for you to feel more comfortable, Chin, I mean, I think you advanced, you ramp it up real quickly, so I'm really proud of you. But yeah, no, there are definitely things we need to fix. But as you said, I mean, that's some material for another day, right? So, all that said, Chin, is there anything else you'd like to? I just stole your screen share. Is there anything else you'd like to tell our audience today?
Look, to be honest, I found this really easy to get started. There's a lot of like go to docs.scilladb.com. There's a lot of good guides there. The university stuff is good as well. But yeah, I was able to sort of, I think being honest, this was about, I got to this point within about, I don't know, maybe a day of work of just sort of like reading docs and trying to, I stumbled a bit with Docker Compose and things like that, but that was just more from lack of education. So I found it pretty easy to get up to the point where I'm writing data into the database. I definitely got all my queries wrong, but yeah, I'm looking forward to kind of fixing that in future sessions.
Yeah, no, sounds like a plan. So guys, me and Chin would like to invite you to our next sessions on ramping up on this application, getting great performance out of it. Thank you so much for attending our webinar today, and we hope to see you soon. Bye.
See you guys.